For today's video, what we're going to do is take a look at two-column proofs when you're dealing with quadrilaterals. So, day 12 of your packet is just a could do section. So, quick little review. There are 4 ways that we have learned how to prove any triangle congruent, or any triangles. We have side, 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 angle, side, angle, side, angle, and angle, angle, side. Now, remember that there are 2 that you cannot use. You cannot use angle, side, side, and you cannot use all angles when trying to prove triangles congruent. Now, we do also have this other method, which is hypotenuse leg. Hypotenuse leg is for right triangles only, but keep in mind that just because you have a right triangle does not mean that it's always hypotenuse leg. It's kind of like a last resort. Even when you have right triangles, see if you can use one of the other 4 methods, and then as a last resort, you have hypotenuse leg that you can use if none of the others work. Alright, so I'm going to do one of the proofs in your packet with you, and then let you do the other 2 on your own. So, here's what we have. In this proof, it says that the accompanying diagram shows quadrilateral BRON with the diagonals NR and BO. And then it says that they bisect each other at X. Well, really, the most useful piece of information in that proof, or in that given, is that they bisect each other at X. So what I know is that where the diagonals cross, they cut each other in half. So this piece right here, BX, is equal to OX, and NX is equal to RX. So right there I have 2 pieces of information. Now, I'm out of givens, but remember you have a couple of things that you can use when you don't have anything else listed. You can always look for vertical angles, and you can see if the 2 figures share anything. Well, right away, if I look at what I'm trying to prove that triangle BNX, this triangle right here, is congruent to triangle ORX, this one right there. Right away, I see that I have vertical angles. And that's 3 pieces. So now I can prove the triangle's congruent using side, angle, side. So that's my plan. So let's write the proof up. First thing we want to do is put our givens in there. So it says the accompanying diagram shows quadrilateral BRON with diagonals NR and BO that bisect at X. And that was the only thing I was given. Now, based on that, I was able to come up with 2 pieces of the figure that are congruent. So I know that NX and RX are congruent. So that's my second statement. NX and RX are congruent. Now, what I have to do is give a reason, and if you look in the given, the word bisect is what told us that those pieces were equal, so that's our reason. And then same thing for the other pieces, BX and OX. Again, we know that they're equal or congruent because of the word bisect. Then we have our angles. Angle NXB is congruent to angle RXO, and our reason for that is that they are vertical angles. So at this point, if I look through my proof, right here I have a pair of sides congruent, right here I have a pair of sides congruent, and here I have a pair of angles. So if I'm trying to use side, angle, side, I have my 3 pieces in my proof. Now I can finish by saying that triangle BNX is congruent to triangle ORX, and my reason would be side, angle, side. Okay, so really all you're doing today is reviewing how to write a 2-column proof. The only difference is that somewhere in the problem there will be a quadrilateral of some sort. Alright, so that is it for the could do's.